All right. Hey everyone, I'm Harini and today we're going to be covering Numpy in this recitation. So we'll be talking about how do you install Numpy, how do you initialize arrays, how do you access data, how do you play around with all of this data, and then finally we'll talk about some math operations as well. So to start off with, what exactly is NumPy? It's basically a package that's very fundamental in Python if you want to perform any mathematical, logical operations or any sort of linear algebra operations. This is sort of the go-to package that you would use. It really provides a very versatile set of operations when you want to, say, vectorize your code or do some fast operations on arrays. Today, we'll be talking through some of these aspects, but I strongly recommend you guys to go through the documentation of the different functions that we're going to cover, but also of NumPy itself so that you can really understand what are the different parameters that you can give to the functions we cover, but also just to see how versatile it is. And hopefully, with the help of this recitation, you should be able to do your homeworks pretty smoothly, specifically your part ones, where you'll be implementing MyTorch, which is PyTorch from scratch. So usually NumPy is pre-installed on Colab. You can check if it's available using pip show, and if it's not, you can install it using pip install NumPy and then import it as any other package. So let's now look at initialization. So using NumPy, you can create both one-dimensional arrays, two-dimensional, and really any n-dimensional array. And very common functions that are used to create 1D arrays are arrange and linspace, where in both the cases, you're creating 1D arrays. In np.arrange, you can create an array of the given range. So you can see an array from 0 to 10. And in np.linspace, you can give a lower bound and upper bound for the numbers that you're generating. In addition to that, you can also give how many numbers you want to be generated. So let's say you want to create n-dimensional arrays, and in such cases, again, there are a variety of functions that you can use. If you want to create an empty array, then you do np.empty, which will initialize the arrays with very, very small values or zeros. If you want all of them to be zeros, then you use np.zeros. And if you want all of them to be ones, np.ones. So the way that you call these functions are very similar, where you just give the shape of the array that you want as parameters. It's, as you can see, it's just the functions that are changing. So let's say now you have an array and you want to create another array of the same shape and fill it with zeros or fill it with ones. So NumPy gives you that option as well, where you can call np.zeros like or np.ones like. And as you can see, it will create another array of the same shape as ones array, which was 4,2, and it will essentially initialize it with zeros or initialize it with ones. Similarly, if you want to create an array of a given shape and fill it with a value which is not 0 or 1, then you do it with np.full, where you give np.full with the shape and the value that you want to be filled. So it gives you a filled array of the shape that you specified along with the fill value that you specified. And similarly, you can also do a full like the zeros like and ones like function, where you give a particular fill value and it will create an array with that value and the dimensions of another array that it matches. So let's say you have another data structure, which is a list or a tuple, and you want to create an array from that. In that case, you can directly call np.array and give a list or a tuple, and it will automatically create an array using the list that you've given of the same dimensions. Note that it's not a 4 comma 1, it is 4 comma. So whenever you create arrays like this, you might have to reshape it in order for any transpose or any pivots to work. If you have your data in a text file or in another format, then you can use np.loadtxt or np.load, and it will automatically load it as an np array into the predefined variables. Finally, let's now talk about special library functions. We are going to be covering random specifically here. So, random is again a very commonly used function to generate random numbers. These can be integers, you can generate random floats. Do go through the documentation in order to understand in more detail how exactly you can use this function, because it is very versatile. So if you want to create random integers from 0 to 10 of a particular size, you use np.random.randint. And let's say you want to run this 10 times, and all the 10 times you want the same set of random numbers to be generated. In such a case, you set a seed and then call the random function. This will ensure consistency across different runs. Do go through again the documentation to really understand how to use seed and how to set it up when you're playing around with random numbers. So let's say you want to create an array with random numbers, but you want it to be from a uniform distribution and not simply random integers. There is a function called np.random.rand that will help you do this. This is usually from a uniform distribution over 0 to 1. So if you want to mean shift it and add some sort of standard deviation or variance to it, you can also do that by specifying the formula yourself and then generating just the random numbers and pushing it into the formula, as you can see here. So we'll stop here for this part of the recitation, and we'll start with how do you access and slice data, modify data in the next recitation. Thank you.